I just finished a graduate level semester of machine learning. Oh my God, this class was so hard. Today I want to talk about my experience in graduate level machine learning. At the university that I go to, there are no prerequisites. Well, there are. They're recommended prerequisites, but you don't actually need to have these prerequisites. I am a self-taught programmer. I went to undergraduate university, but I studied biochemistry with a minor in biology, and I also received a second degree in psychology. I had never taken a computer science programming class before. I literally had no idea how computers worked during my undergraduate years. I did take some math classes. I had to do physics 1, physics 2, and I basically did all the pre-med requirements, and that was kind of part of my biochemistry training. Then after graduate school, I went into working in research. So I have other videos where I talk about my background a little bit more, but today we're going to talk about my experience with machine learning. This was my second semester of graduate school, and I'm basically doing a computer science degree. It is computational biomedical sciences, but all of my coursework is heavily on the CS and software engineering side. So my first semester, I took big data management, and I also took design of software systems. In this second semester, I did AI and machine learning. At the university that I go to, AI is a prerequisite to the machine learning class. So I did these two in tandem because, again, there are no hard requirements for the prerequisites for any course. The prerequisites for this course, though, are for machine learning are statistics, linear algebra, and there's an assumed understanding of calculus as well. I would say you probably need up to like calculus 2 or 3 depending on your university, like how they structure the calculus classes. But to do machine learning, you need calc 2 and 3. At the university that I went to, I made it through calculus 2, which is integral calculus. I never did any differential equations, and I did statistics in like the second year of university at community college, and I wasn't prepared for that, and it wasn't something like that I totally learned how to do statistics, and I didn't go into this machine learning class with a strong background in statistics. So what was my experience like with this class? Well, right from the outset, it was made very clear that this machine learning that I'm doing is probabilistic machine learning. In fact, we used the textbook, the Kevin Murphy textbook on machine learning, which is a probabilistic approach. A lot of the machine learning that I had seen and been exposed to is more on the algorithmic side. So if you watch like Andrew New's machine learning playlist on YouTube or Coursera, there's math involved, but it's more of this algorithmic approach to machine learning. And if you watch other YouTubers, or at least the YouTubers that I've seen, a lot of the machine learning stuff is like how to do machine learning in Python. And it's mainly just like using the pre-built functions for performing machine learning. So going into it, I wanted that knowledge. I wanted to know how to engineer and program machine learning solutions. But what I got instead was this very rigorous mathematical approach to machine learning, and it was extremely challenging for me. Some of the questions on the homework came right out of the textbook, the machine learning probabilistic approach textbook. And these questions included things like prove this equation. So like come up with a proof for this equation or derive this equation. That was miserable for me. It was so challenging for me to figure out how to do that. Even if the parts of the solution were in the textbook, it was still so difficult for me to just break down the equation, understand the equation, and then go through the process of writing it out on my own in a way that I actually understood it. This was very difficult. I had taken physical chemistry in the past before, and physical chemistry was another very challenging mathematical course, and it required very rigorous mathematical equations and showing all of your work. My professor was really good, and he taught me a lot of core skills that I needed, but I hadn't done it in like 3 years. I hadn't really done a lot of math in like 3 years. And again, my background in statistics was just not fully there. I'd never taken a probability class. So the first part of this machine learning course was like the introduction to probability and the ramp up. So you learn things like distributions. We learn things like the maximum likelihood estimation. Even to today, like I just finished the class, so I still need to kind of digest all of the stuff that I did. And I just realized that if you want to get good at machine learning, if you really want to get good at machine learning, you need a very strong mathematical and statistical background and understanding. So what are the things that I got out of this course? I really liked to have the experience of actually building machine learning models. One of the main reasons why I started learning to program was so that I could do machine learning. Actually, the thing that I really wanted to do was deep learning. For some reason, when I hear about deep learning, when I was reading about deep learning, listening to lectures on deep learning, there's just something that made sense about that approach to programming computers to learn on their own. I felt like going into this course, I had a good theoretical understanding of what machine learning could solve, like what types of problems, and I knew what I wanted to get out of it. But doing the actual work was extremely challenging, and it caused me to burn out multiple times. I became very, very burnt out during this course. One of the difficulties of this course also was that there were group assignments, there were individual homework assignments, there were weekly quizzes, and there was a midterm and a final exam. It was like all the time doing something. I was either doing a quiz, doing a homework that was due, doing one of the group assignments that was due, preparing for the midterm, just trying to understand what I'm doing, just trying to understand the concepts and read and stay caught up. And it was so overwhelming that I felt like I was constantly playing catch up, especially because I didn't have that mathematical background going in. So now that I'm done with it, immediately, after finishing the course, I'm feeling elated. I'm feeling very good that I got through this, that I finished this. Overall, I'm glad that I took the course. I do wish that I had more of a mathematical background going into it. I think I could have got more out of it, but just from the way that my university is structured and set up, I'm in a PhD program, so the emphasis is not on coursework. You really don't want to be taking too many classes. And I didn't want to go through all the prerequisites. I mean, I just couldn't. I really only do courses in the first 2 years. So I can choose like up to like 6 classes that I can take. And in the first semester, I couldn't get into machine learning or AI. So I couldn't do either of those. But it probably would have been a better experience had I done AI first and just gone through the whole semester and then went into machine learning. Because in my AI class, we are doing machine learning. Like the second half of it is all machine learning, and it's starting like really basic. Because I did this machine learning and AI class at the same time, I needed to do less work in the AI to understand the machine learning topics, but it was challenging that for me in the machine learning class. Like I spent way more time on the machine learning stuff. AI was an awesome class, is an awesome class. I'm still in this class. And I definitely want to make a video about that separately and talk about some of the differences between ML and AI. But I will do that in another video. Let's wrap up here talking about machine learning. What do you need to do if you want to learn machine learning? This is like one of the questions that I've always had, and now I feel like I kind of understand it that I went through this course. So there's kind of like 2 things that you can do in machine learning. There's just programming. You can program machine learning solutions, but if you're going to do any of that at a serious level, then you need to understand what's actually going on, like what the machine learning algorithms are actually doing. So you need some understanding of the math behind machine learning. And machine learning, it sounds fancy, it sounds cool, right? Machine learning, it's very well branded, but it's statistics, it's probability, it's linear algebra, it's calculus, it's math. So machine learning is math. If you say you want to do machine learning and maybe you go on and you see like Centex on YouTube programming these machine learning algorithms, you can do that and you can get something out of it. You can have some understanding of what's going on. And I think somebody like Centex who just like he's like built up such a deep level of understanding through the programming. Like I think he like learned a lot of the math and like how the algorithms actually work through the programming implementations, through the Python implementations. And that's actually a really good way to learn. Like if you want to learn, just jump in and start doing things. But at some point, you're going to need to understand some of the math that is going on. And you're going to need to understand like matrices and like the operations that you need to perform on matrices. So, understanding like NumPy. And you can kind of look at like the Python implementations as learning tools to learning some of the foundations of machine learning, because these implementations in Python are engineered from that understanding, from the deep understanding of the actual like machine learning that's backing those things up. As part of my training this semester, I needed to understand these implementations, and in some cases, I even wrote my own implementations, and I did that as exercises or projects, But like one of them, for example, was I implemented an EM algorithm, an expectation maximization algorithm for a Gaussian process, and there's an implementation in scikit-learn. So while I was doing this, I did it on my own, and then there was one point where I was kind of getting hung up on something, and I went through the scikit-learn implementation, and I actually saw that there was a lot of overlap between the way that I was structuring it, the way that I was doing it, and the way that scikit-learn did it as well. It would take me a lot more time to like clean up that code and get it to the level of scikit-learn, but I could see that I was kind of like on the roadmap to getting there. But, in my project, it was like a 2-week project. So I just needed to like get it done. There was another component to it too. Like the first part was like program the EM algorithm. And then on top of that, add in this other logic to it. And that was actually for AI. But the point is that like my discovery process through taking machine learning was that I really like understanding the math, and I'm going to continue to learn. I'm going to stay consistent with it and keep exposing myself to the statistics. I spent a lot of time like trying to understand that, trying to play catch up as much as possible and get up to speed on things. But I definitely realized that, I love machine learning. My intuition was correct that I wanted to learn to program to do machine learning, to work with data. So I'm super happy that I went this route. I'm super happy that I took this course. I'm happy that it's over. I haven't gotten the grade yet, but on the final exam, I got a 98 out of 100, and I felt very good with the way that I was doing on that final exam. And the other thing that I was like super happy about was the last group assignment. I needed to do a small project. It's kind of small, but I had to program an autoencoder, which is something that I've always wanted to do. When I learn about deep learning, I always felt like learning unsupervised methods for making sense of data is something that's really powerful. And autoencoders, variational autoencoders, something that I really wanted to learn how to do. So I had the opportunity to build an autoencoder, and also the goal of this project was to take layers from this autoencoder and use them to train a classifier. So I did autoencoder and transfer learning, and those are two things that I've just heard a lot about as being very powerful, algorithm and technique in deep learning and machine learning. And for the types of data analysis that I'm doing, those techniques could be extremely powerful. So I'm super happy that I got to do that. I felt very fulfilled by being able to do that. So this has been my experience with machine learning. It's very heavy in math. It was a very challenging course. I wish I could do it again. I would literally do the whole thing again and feel like it would still be hard for me. I think I could do that entire class again and it would still be challenging. I think I would have to do that class like 3 times before I became like really proficient at it. And that's just part of any difficult subject. You the only way your brain is going to remember something is if you're continuously exposed to that information just over and over and over and over again. Going forward, I am going to include more machine learning in my programming. I look forward to just continuing on. And if you feel like machine learning is something that you want to do and something that you want to get into, trust your intuition. I think that just goes in general. Just trust your intuition. Find a way to just get into it. Start just getting into it and working through problems, even if it feels really uncomfortable. In fact, if it feels really uncomfortable, you know that you're learning. You know that your brain is struggling to make sense of the information and to learn something new. So that is a good sign, and you should keep going for it. Machine learning is awesome. And it definitely takes like a certain mindset, a certain personality, a certain way of thinking. But if you feel that you have that, trust that and go for it.